distributions of the positions of particles and how those distributions evolve with time. So I don't even try to tell the public about how I infer the initial conditions of those particles from knowledge of the final conditions, because of course that uses the backwards Fokker-Planck equation, which gives completely the wrong impression of me. So, to change the subject then, I'll instead talk to you about some of my lectures. So, let's pretend that this is one of my lectures, and you're my undergraduate students. So, hello everybody, and welcome. Welcome, yes, yeah, exactly. Oh, good acting. A little bit too much interaction there. So, welcome to this lecture course on vibrations and waves. I'm your lecturer, Dr. Evans. Call me Mike, and I will hurt you. No, of course, I don't really say that. No, I think it. Apparently, I'm not allowed to hurt the students. Something to do with league tables. So, in today's lecture, we're going to study the phenomenon of resonance. Now, resonance occurs when you have an oscillator, and you force that oscillator by pushing it at a frequency that matches the natural frequency of the oscillator itself. And then, when you do that, you get a very big response from the oscillator. So, I have a demo to demonstrate this. I should explain, I used this demo in my lectures for several years running. It's a very simple demo that I can take into the lecture theatres very easily. It's just a mass attached to a piece of rubber so that it wobbles. And I used this demo successfully for several years, and the students diligently took notes and learned from it. And then one year, I don't know why, there was something different about the atmosphere in the room. There was a bit of a commotion up at the back, and I thought I heard a bit of sniggering. And then suddenly, I realised why. I had this moment of what I can only describe as Buddhist enlightenment. But I suddenly was completely self-aware. I could see myself with absolute clarity. Now, what do you say when you suddenly realise you're standing in front of 170 people, gently waggling a massive rubber phallus? Well, I heard these words escaping my lips. No horses were harmed in the making of this film. Now, interestingly, those exact same words were later quoted back at me during the end of semester assessment of teaching quality. True story. But what that proves to me is the students learned something. They remembered something from my lecture. So I count that as a success. Another of my teaching triumphs occurred a couple of years later when I was teaching a lecture course called Advanced Polymeric Fluids. And for this lecture course, I did a demo as well, and I wanted to demonstrate the phenomenon of a shear thickening fluid. So I made up a batch of starch solution, very much like this one. You might have seen a demo like this before. It's actually, you can make starch solution, kind of starch solution, just by mixing corn flour with water. And starch molecules, they're actually tiny little microscopic beads, rather like grains of sand. And starch solution, it's a runny fluid, it flows, you're right there, yeah. If you pour it gently, it sloshes about. But if you apply a large force to it, then it solidifies, its viscosity goes up very rapidly. And it's just like if you try and pick up dry sand at the beach, then it flows through your fingers unless you squeeze it hard enough, and then it goes like a solid. And this phenomenon, it's actually not fully understood, that the statistics of all the interactions between the particles that lead to this jamming transition are actually an active study of theoretical research. But experimentally, it's well established that if you slosh it vigorously enough towards a student, then its viscosity will go up and the student won't get wet. And I would like to recreate that demo for you here this evening. Evening, sir. Don't worry, there's no audience participation in my act. No, all you have to do is sit there. Are you sitting comfortably? Good, I'm glad. I wouldn't want to make you uncomfortable. Now, yes, I see what's going on here. I see what you're all thinking. You think that I got the mixture wrong and the student got wet, right? You actually think that I'm that unprofessional as a lecturer and as a scientist that I wouldn't practice this demo over and over again until I was absolutely sure it would work. Well, frankly, I'm offended. No, I got the mixture absolutely perfectly right. Thank you very much. And in case you're wondering, I also made absolutely sure that I kept a really firm grip on the handle of the jug. Interestingly, the handle itself separated from the rest of the jug, which continued forwards at really quite high speed towards the student's face. And at that moment, an exclamation escaped my lips. I believe I may have involuntarily referenced the Fokker-Planck equation. You see, what had happened was just here, where the handle attaches to the jug, the plastic's quite thin, and the plastic there had developed a stress fracture. Ironically, because of all the practice I've been doing. Now, those of you who've been paying attention will remember that we're discouraged from damaging students. And that's what alerted me to the fact that smudging a student in the face, actually in the middle of my own lecture, while screaming profanities at him, is not university policy. It doesn't appear in our mission statement. I checked, just in case. But as it turned out, the student in question was largely unharmed, and in fact, he turned up again to my very next lecture. He even sat in the front row of the lecture theatre again, which was surprising, and it was very brave of him. Don't you agree, sir? Yes. So, there are, however, two crucial points that you need to take home from this whole event. First of all, the student didn't sue. And secondly, and I think most crucially, when that jug impacted that student's face, the stresses involved were really very large. So the non-Newtonian fluid instantly solidified and it stayed in the jug. So I count that as another success. Ready? Right, quite runny. Would you say that's quite runny, sir? Quite runny. Ready? I'll take that as a yes. Yes. All true. Questions? No questions.
That'll be a question.
Thank you very much for your comment.
Any questions at all? Go on then.
Have your students ever played tricks on you?
Oh.
Because there are some classics. Absolutely. Any undergraduates who want to know them afterwards, just have a quick look.
Don't comment. Don't do that. I will end you.
My students, I can't think of a time when my students have played tricks on me, but it's true what I said about the end of semester assessment of teaching quality. So at the end of each semester, the students actually hand out questionnaire slips to give their comments on the lecturer. Please set us more homework. This kind of thing. You know. And yes, in fact, that year, 2 of the students simply wrote on their comments, which goes then to the head of school. They simply wrote, "No horses were harmed." Left it hanging.
Have you ever been sued?
Not yet. I was in 2 minds about revealing any of this story. It's probably best if it doesn't go public, but it's just being filmed, isn't it? Yes, we'll have to talk about that.
So I have a question. You use this one and you say no horses were harmed. So does size matter? If you were to use a smaller one, what would change the frequency? How would it alter the demonstration you were showing?
Well, obviously it would be less impressive. Agreed about that.
Would it scale? So if you change the girth, what would happen?
Glad to hear it.
Do you have a personal interest in it?
Most likely.
I mean, I've been practicing in front of a mirror. I just wondered.
Do you want to get over it? Is that what you're saying?
Sorry, you want to give it 2 more answers. It's fine.
No, I'm a physicist. That just doesn't happen. 2 word answers. Now then, I happen to remember that the bending stiffness of a rubber cylinder scales as the cube of its radius. Yeah. And the frequency scales with the square root of the bending stiffness. So, double the girth and you will increase the frequency
There's a blackboard over here.
by a
a
factor of 2 to the 3 halves. Thank you very much. Thank you. Not expecting that kind of heckling.
Any less phallic questions? Alright, any phallic questions?
Let's talk about the Fokker-Planck equation later.
Go on then, Sarah.
No, that needs more beer.
Does it? Okay. So, until our speakers have been inebriated enough to talk about their real research areas, I would just like to take this opportunity to thank all 3 of our speakers tonight for an amazing talk and an amazing evening. So thank you very much. I'd like to remind you of the PubHD principle of putting a pint in the hand of the person you would like to ask a question to. So if there's anything you'd like to discuss or bounce ideas off anyone, please do buy them a pint.
Oh, I'm full of ideas.
Yeah. And also, I guess the thing that's been running through my mind all night is we all do outreach and we're all really encouraged to do outreach and talk to the general public. but actually talking to a mixed audience of peers and the general public and everybody that you could possibly imagine turning up to a pub to listen to a talk is incredibly scary and a really, really good skill set. So well done to everybody who's tackled that challenge tonight, and hopefully we're going to do more of these. So thank you, enjoy, eat and drink and have fun.
Or Dave.
Go on Dave, say something.
Or Dave.
Is it karaoke time? Ding, ding,
I think the bar's still open.
I'm waiting. Oh, there's a lot.
What's your valid question about his line to do when you